If f is a polynomial function, the values for x, for which f of x is equal to 0, are called the zeros of the function. These values are also called roots, solutions, or x-intercepts. At this point, we will find these by factoring, like we did in section 1.6. In section 3.4, we're going to learn how to find these for polynomial functions that cannot be factored using the methods that we know. Multiplicity tells the number of times a zero or factor is repeated in a polynomial function. For example, if x minus 3 squared is your polynomial function, then x equals 3 is a 0, because 3 minus 3 is 0. And it has multiplicity 2, since the factor x minus 3 is repeated twice because of the squared. Multiplicity gives us a connection between the equation of the polynomial and how the graph behaves at the x-intercept, meaning whether it just touches the x-axis or completely crosses the x-axis. Okay? So multiplicity will tell you if your x-intercept does this or whether it crosses through. Okay? So that's what multiplicity will tell us. If a 0 has odd multiplicity, then the graph crosses through the x-axis, okay, like this one. If a 0 has even multiplicity, then the graph only touches the x-axis, like this one. Example 4, find the zeros of f of x equals x cubed plus 3x squared minus x minus 3. So again, for now, we'll do this by factoring. Okay, so 4 terms, you should think factoring by grouping. Okay, so group the first 2 together, group the second 2 together. The first 2, this is a coefficient of 1, so just look at the x's, x cubed and x squared, so we can factor out an x squared. Okay, if you take x squared out of x cubed, you're left with x. And if you take x squared out of 3x squared, you're left with 3. Okay, negative x minus 3, they both don't have x's, and the only thing we could factor out of them is a negative 1. If you factor out negative 1 out of negative x, you'll be left with an x, and out of minus 3, you're left with positive 3. Okay, so your polynomial fully factors into x plus 3 times x squared minus 1. And you can factor this one more time. X squared is a perfect square, so is 1, and that will factor into x minus 1 and x plus 1, difference of 2 squares. So your zeros, if x is negative 3, that will be 0. If x is positive 1, 1 minus 1 is 0. And if x is negative 1, negative 1 plus 1 is 0. Okay, none of your factors are repeated more than once, and they don't have any powers on them. So all of these multiplicities equal 1. Okay, so multiplicity equals 1. And that means that all of these will cross the x-axis. Example 5, find the zeros of f of x equals negative x to the 4th power plus 4x cubed minus 4x squared. Give the multiplicity of each 0 and state whether the graph crosses the x-axis or touches the x-axis at each 0. Okay, so this one, not 4 terms, so we should not be thinking factoring by grouping. First, we should be thinking factor the greatest common factor. All of these have an x, and in fact, they're all at least x squared. So we can factor out an x squared as the greatest common factor. And also, to make things easier later, most people have an easier time factoring if their first term is positive. So let's factor out a negative x squared, which when we factor will make the first term positive, second term negative, last term positive. Okay, so negative x squared out of negative x to the fourth leaves positive and x squared. A negative out of a positive will make negative 4. X squared out of x to the third power leaves x. A negative from a negative will leave a positive. And x squared out of x squared, it just leaves the 4. Okay, so now x squared minus 4x plus 4, there's no number in front of x squared. So just look at the c term. 2 and 2 will add to 4. Negative 2 and negative 2 will add to negative 4. And so this will factor into negative x squared times x minus 2 times x minus 2. And since there's two x minus 2's, typically we write that as negative x squared times x minus 2 squared. For the zeros, if x is 0, you have 0 squared is 0 times anything will be 0. And 2 minus 2 is 0, and that will make that 0. So 0 and 2 are the zeros. Because of the squared on the x, 0 is repeated twice, and because of the squared on the x minus 2 is repeated twice. So both of these have a multiplicity of 2, since they're both repeated twice. And that means that they just touch the x-axis. They don't cross through. Example 6. Find the zeros of f of x equals 1/2 times x plus 1 times 2x minus 3 squared. Give the multiplicity of each zero and state whether the graph crosses the x-axis or touches the x-axis at each zero. This problem is nice because it's already in its factored form. Okay, so we can go immediately to these zeros. X equals, if x is -1, -1 plus 1 is 0. And 2x minus 3, if you set that equal to 0, add 3, divide by 2, and you'll see 3/2 is the 0. For multiplicities, -1 came from x plus 1, so it has multiplicity 1. And the 3/2 came from 2x minus 3, which has the squared, so it has a multiplicity of 2. So this one crosses, and this one just touches. Okay, also notice I didn't do anything with the 1/2 in front because it doesn't have an x. So there's nothing you can put in because there's no x. So 1/2 will never make this polynomial 0. So you only need to worry about what's in front if there's an x that's been factored out to the front. Okay, so for graphing polynomials, we can use the end behavior, zeros, and multiplicity along with your graphing calculator to graph any polynomial function. Knowing the end behavior and the zeros will allow you to ensure your calculator is showing all of the important parts of your graph.